All right, so you should have tried number one and number two. Number one and number two. We're going to do number one slightly different than the way we've been doing it all along, although you get the same answer. Just the way we write it's going to be just a little bit more thoughtful than we've been in the past. X plus 2. 2. Okay, so we're going to remember right at a 1 over here. 1 dy equals x plus 2 dx. I'm ready to integrate. My variables are separated. I get y equals 1/2 x squared plus 2x plus c. And there's my general solution to the differential equation. And again, you could have done this before we ever said the word differential equation, so don't panic. 2, though, is where we start to get things interesting, right? This is the new idea. Dy dx equals y plus 2. My y is on the wrong side, so first thing to do is I'm going to move it over to the other side so I can separate my variables. End up with a y plus 2 over here dy equals 1 dx. Because when I divide by y plus 2, I leave behind a 1. Everything's separated. My variables separated. I integrate, and I'm going to get down here, I'm going to have to set u equal to y plus 2. So du equals 1 dx, or sorry, dy. So I already got a 1 dy, so this is ready to go. So I'm going to integrate 1 over u du, which gives me ln absolute value of y plus 2 plus c equals x plus c. Same trick as before. C plus c, c minus c, c divided by c is just another variable that I haven't yet found. So I'm going to go ahead and get rid of the c on the left side because I don't want to deal with it. I'm going to realize I have an ln over there, so I'm going to go absolute value y plus 2, and I'm going to go e to the, I probably should get rid of those parentheses, but I'll put those equal signs, I'll put equal signs down here and get rid of these ones right here. To get rid of the ln, I swing the e back across. To get rid of the absolute value bars, I recognize, well, actually, before I do, let me finish this, and then right here we're going to do something different on our second pass. Okay, but to get rid of the absolute value bars, I'm going to go y plus 2 equals plus or minus e to the x plus c. And then I've got my stinking plus 2, so I'm going to go y equals plus or minus e to the x plus c minus 2, and here's my general solution to this equation. General solution. Now, another way to look at this is interesting. If I note that addition, so I had this right here, and I said, let's talk about this in a slightly different way. There's another way to do this with the variables. It actually has huge advantages, and that is this. Oh, I wanted to do it before I moved the plus or minus over, so I probably, sorry about that. Okay, so now I'm looking at this, and I've got this situation. I should note the following, that because I have a plus up here, because I have a plus sitting right here, I can rewrite this as y plus 2 equals e, this is a c. I'm sorry I'm messing this up so badly. See that right there? I'm just taking this equation here, and I'm putting it up here very poorly. Okay, so I had e to the x plus c. If I have e to the x plus c, I can rewrite that as e to the x, e to the c, because remember, if the base is the same, I add the exponents. And so that's exactly the same equation, right? And e to the c, well, that's just some number, isn't it? So I could rewrite this as c e to the x, meaning e to the c is, well, c, multiplied this time instead of added. Now, again, this happens because I have a plus c raised to a power, because when I swung the log over, the e to the whatever, I end up with x plus c up high. Okay? Now, before I move out much further, some people can't deal with the fact e to the c becomes c. That's just, I mean, there's a lot of bad things. C plus c could be c, c divided by c, two c's and a c could be c, but c, e to the c is c? I can't do it. So what people do is they make this a k. Yeah, I kid you not. So e to the c is now k. Fair enough? You can pick any letter you want. We'll make it k. Okay, now the advantage of this, one of the first advantages of this is like, the next thing I'm going to do is get rid of the plus or minus, right? Because I get rid of the absolute value bars. Well, is k positive or negative to begin with? We don't know. So plus or minus k is just, well, k. And how do I get rid of that too? Now, there's another advantage to this particular way of writing. By the way, these are equivalent, right? These are the same thing. Okay, written slightly different. One of the principal advantages of this is if I'm careful, my initial conditions are much easier to find, because if I make if I make x equal to 0, right, then that becomes 1, so it's k minus 2 as your initial conditions. Whereas down here, remember we did in the previous problem, c became the ln of something, and it's always become the ln of something if I leave it like this format over here. Okay, so this is generally considered the way most people do it and the way you should recognize it. Is the first way wrong? Not at all. Okay, it's just more convenient to write it in the right-hand side way. So we're going to write it in the right-hand way 90% of the time. If you want to fight it every single time, feel free to do so. Just make sure you recognize that this is one way it can be done, because again, multiple choice tests, it could be written this way and you have to match it. Okay? All right. This problem is, I don't think, anything like the problem that follows it. So go ahead and try the practice problem, and then we're going to do a couple more problems, and then we'll be done with this worksheet in no time, and you'll enjoy it. Okay. So try the solve problem, and then try the problem number 5, and then come back over here, and I'll do those 2 problems, and then we'll finish this for homework, and you should be good to go. All right, let's do those 2 problems we were talking about. So the record problem. So solve problem. Well, dy dx equals y cubed x. Separate your variables. 1 over y to the 3rd. dy equals x dx. I get, this is y to the negative 3rd dy, integral x dx. So I get y to the negative 2 divided by negative 2 plus c equals 1/2 x squared plus c. Again, waste of time. So I'm going to get 1 over y squared. I move the c's over because I'm bored with them. I've got a negative 2 over here, negative 2, 1/2 x squared plus c. I've got to get rid of the negative 2, so I'm going to do that. 1 over y squared equals negative x squared. What's negative 2 times c? Of course, it's just c. Yeah, getting used to that. That's fun. Okay, so I had to get rid of y squared. I'm going to move it to the side. I get negative x squared plus c times y squared. Move it to the side. I get 1 over negative x squared plus c. That's y squared. And yes, let's finish this up with an ugly square root bar. Yes. Yes. Okay, so there's my practice problem there. And then I'm going to try number 5. Number 5, nice easy problem, looks like, from just looking at it. Dy dx equals 5x over y. Move the y over. I get dy equals 5x dx. That feels ready to go. I go 1/2 y squared plus c equals 5/2 x squared plus c. Move the c's over. I get 1/2 y squared equals 5/2 x squared plus c. Yes, because c minus c is clearly c. Multiply both sides by 2, and yes, I get 5x squared, plus obviously 2 times c is still c. Yep, and then y equals plus or minus the square root of 5x squared plus c. That's fun. There's your solutions. Finish this worksheet, and who knows, maybe sometime this summer we'll actually get to doing the problems. For the questions, send emails. That would be groovy.